Good evening. This is Minjan from Momentum Learning. Oh, I did not put that one here. Anyway, this is open class for APCS principles. How to prepare for this exam if you're taking the class. This is a chart for some of the AP exams. Here we have taken some of them, and many students might have to take these. If you look at the distribution of the schools, so school 5 all the way through 1 here, for school 5 percentage, the lowest actually would be physics 1, the second lowest, APCS principle. And you might be a little bit surprised why AP Calculus BC has the highest rate of 5, 48. Almost half of the students taking this AP exam would score 5. But we all know, right, ABC, Calculus BC probably would be the most difficult subject among all these exams. But why the rate is actually the highest? Well, many students, many parents have asked, well, physics 1, since many students think this would be, the first science class, could be chemistry, could be physics, could be biology. Turns out this one is harder. So the denominator is large, i.e., there are many students who take this exam. So if the denominator is big, the number of people who can score 5 is small, then the ratio would be much smaller than the others. And then this one, APCS principles, actually, it is relatively easier than APCSA because here actually you don't have to do the intensive programming. APCSA actually you have to, both in the in class you have to work on projects, and also in the exam you have to know how to do computer programming. But the percentage of getting 5 right actually is higher, much higher than this one. So again, most students taking this one thought this one is easy. So the denominator for this pool right actually is big. So the ratio actually dropped. So this turns out to be kind of interesting. If you want to get a 5, you need 85% of the score out of 100, right? 85% to get a 5. That is actually easier than the standard you get NA in many schools. In many schools, you need to score 90 or above. Some schools may say, okay, you need 93 or above to get an A. And I'll be the instructor for this class. And here is a brief resume of my teaching experience. Many of you have known here at Momentum Learning, we have done a lot of competitive math, competitive physics, competitive computer science. I've been doing the teaching for competitive programming USCO, i.e. For many years. And then also we have added the AP classes, APCSP and also APCSA. They will be both offered this semester. So in the spring semester, we do offer these 2 classes, and then this one is offered on Saturday evening, and then the APCSA is offered on Sunday evening. The main goals, these are the goals listed in the guideline. If you check the guideline from College Board, these are the goals for APCSP class. To be honest, right, to be fair, after taking 1 year of the APCS principles, students actually cannot truly reach these goals. So that is actually the long-term goals. For example, right, computational solution design. So basically, for a problem, for a task, if we want to solve them, we need to develop the idea, take the approach, right? You need to design how you solve it. And if you think this idea works, right, present the solution so that either the team or the group, right, we're going to agree, okay, this is actually a viable solution. And then we're going to say, try to implement, try to design algorithms, try to take whatever data structures and develop the program to solve the problem. And here, even though we're not going to do the actual implementation or the development, right? So we're going to learn the idea how to do the abstraction. And this is actually one of the main ideas in the object-oriented programming. So maybe the project is huge, involves maybe tens of people, hundreds, sometimes even bigger, right? big team. So how do you coordinate, make sure all the parts they'll talk smoothly without causing the the trouble or the bugs? So this is actually a very important idea, and we're going to learn something from them. Actually, for each of these goals, we're going to learn just a little bit. And then the idea is, well, once you have the idea, get exposed to these concepts, and then later, maybe still in high school, in the APCSA class, and also later in college, and also in the graduate studies, you're going to get more and more practice or experience and get a deeper and deeper understanding of all these. And they're actually very important. Okay, so the goals are set very high, and we're going to get exposed and also get trained again and again, and especially in the current environment. As AI comes here, this actually becomes even more important. The last one, responsible computing. So actually, this will be one of the main big ideas. Okay, here the whole curriculum would be designed around these 5 big ideas. Creative development. If you want to solve a problem, well, must be the case, right? If you already have a solution, then you don't have to worry about it, right? If you need to solve a problem, that means, right, there's no solution. So you have to do something that is different. Here, we say that it's creative, right? You have to be creative to find a solution that can solve this new problem, this new question. This big idea actually takes the percentage in the exam, the end exam, the multiple choice part, right? 70 questions, actually, this will take about 10 to 13%. Data, this is actually a big one. How do you collect the data? How do you clean the data? How do you analyze the data? And also how to store the data. So this actually is also an important part. Especially now we talk about big data, right? Everybody's talking about, okay, we have so much data and how to store them, how to use them. So that is a big component. And the third one, actually in the middle one, that's the biggest component there would be the algorithms and programming. So you need to design algorithms to solve the problem and also try to implement. So here will involve, right, the design and development. And this part actually would be most people refer to computer programming. So many programmers will spend hours and days, months, years, right, to finish the program. And also another part would be you're going to check it, test it, whether the program is actually working as intended. So we talk about a lot for the testing and then debugging. Of course, right, every time you solve, find a mistake, right, remove a bug, probably you're going to introduce or add more bugs. So this will become, the cycle, right? Every new release of a program, you're going to say, okay, we have fixed some of the bugs that from the prior releases versions. But then, of course, right, we're going to add more. So we're going to release more, new versions in the next year or next 2 years. So that becomes an interesting cycle until if the customers lost interest to this program, then we're going to develop some new programs, new products. This part for computer systems and the network, right, that will be touched. Well, we all have the idea, right, internet, and that becomes even more important now since every computer, not just computer, right, every computer, every phone, every digital gadget, right, will be connected. So it becomes important for safety, for privacy, and so on. Okay. This part, I just talked about the impact of computing. So how do you make sure your computing, your contribution to computing, right, actually would it be responsible? Every time you do something, actually, it will have an impact. So we try to make positive impact rather than the negative. So as we become more and more powerful, how do we make sure, right, we only do good things, not the bad things? So actually, many students in the past years, right, especially younger students would always ask, right, Dr. Ming, can you teach me how to do to be a hacker? How to write a virus? So this would be, sometimes kids are curious, and it would be kind of the instinct, right? I want to write something. Once I become more powerful, right? If I want to try it, right? Then here, always keep in mind, make positive impact to the computer programming. All right, so all the curriculum, APCSA class and also APCSP exam would be around the 5 big ideas. Keep in mind one thing here, I want to make it really clear, right? No programming is needed for the multiple choice section. The 70% of your APCSP exam does not need programming. Even though in the questions, you're going to say, okay, this is a piece of program and how do you analyze it? Well, all those codes actually would be called pseudocode. It's not really an actual computer language. Even you don't do programming right, you can still understand it because mainly it will be written in English. Okay, so but still, if you do have prior programming experience, it can actually will help. It can help you to read those code and also for your project later, right? Anyway, you have to develop a program for the task. Okay, so we recommend, if possible, right, get familiar with the Python program because Python would be easier. It takes less time to get started. If you want to do Java, C++, that's fine, but Python would be much easier, or JavaScript. These are the things that you might want to know how to use them. So this is referring to Python. How do you write functions, right? How to write loops, how to do conditional statements, lists, sets, and dictionaries. These would be very useful for you to develop your program for the project task. And also you need to get familiar with debugging and testing because you need to include that in the task. Okay, and also, right, you have to document. For some students, right, this one is not an issue because now Python is so popular. So you can even take Python first. Once you are familiar with Python programming, then taking the APCSP class, right, would be much easier. The performance tasks, even though it's not in the final end exam, this one is not in the last 3 hours exam, you're going to do that one in class. These are from the guidance from College Board, and I hope you would read carefully. For example, right, you need to explain the importance. You need to emphasize the focus. No matter what project you choose, right, choose a meaningful project and explain these, right? These are the philosophy or the idea we normally teach. Okay, if a big a project, right, that may be big at the beginning, right, break them or partition them into smaller tasks and try to solve each part, and then you can put them together, right? Combine the solutions to each task, and then at the end, right, you're going to have a solution for the original project. Document for every step you have worked on. And also, right, you can always seek feedback from your peers, from your teacher. And actually, during our class, right, we also offer the service. Some students say, okay, I'm working on this project, right? Can you help me to take a look, right? Maybe I got stuck in the debugging process, or I don't know how I can solve this part. Maybe this part is too hard. So can you help? Yeah, we'll be happy to do that. Here is a list of 4 problems, sample questions that you would see in the exam. So that would be the end exam, 70 multiple choice questions. For example, right, this one talks about which of the following is not true about a computing innovation. Okay, so this is pure concept. If you know the definition of computing innovation, then this is easy. If you don't, this may be a little bit hard. So here, right, just read it. Computing innovation includes a program as an integral part of its function. Okay, sounds good. Computing innovation can have physical side in it. Computing innovation can be non-physical. Computing innovation can be purely hardware. If you have not done it, This may be out of nowhere, right? I'll just make a guess. Well, by definition, computing innovation must have a software component. It can have hardware or not, does not matter. So choice D is actually the answer. Cannot, if this one only has hardware, then cannot be classified as computing innovation. So the answer is this one. All others, right, can happen. So again, right, if you know it, if you know the definition or have seen it before, then that's easy. But if you don't know, then it's hard. So you need to practice, read through, say the guideline, and also sometimes write the textbook so that you know what it is talking about. Okay, so computing is common word, innovation is common word, but put them together, right? Actually, that's a terminology. This one is actually a common one. It says we have a computer that has two identical processors. They can run in parallel, and we have three processes. They can be run on either processor. If they run it on any one of the processors, process X will take 60 seconds, process Y takes 30 seconds, Z takes 50 seconds. What if we can run them in parallel? Okay, each process has to be executed on one processor. Cannot be say part of here. That's not important. That's impossible. Okay, so if we do allow those kind of parallel computation, what is the minimum amount of time to finish all three processes? Of course, right? The answer is the format is not like this one here. You'll be given the choices A, B, C, D. But here, right? Think about it. How do you make this one shorter? Well, the easy way would be we're going to let the longer one run by itself. So it would be here. This is X, will run 60 seconds, and we're going to run Y, that would take 30 seconds, and we're going to put Z here. So that would be 60 here, 30 plus 50, so that would be 80. So here, the minimum amount of time to finish all three processes actually would be 80. Okay, if you allow split the process Z, right? Part of it will be here, part of it will be here, then we'll just say add them together, divide by 2. But if you cannot, so each processor must be executed on a single processor, then, well, you cannot do that one. So here must be 80. Okay, so that's still common sense. So if you understand it right, this will be, again, easy. Again, if you have not seen it before, right, say an 8th grade, without taking the class, right, if you want to answer the question, maybe a little bit hard. What do you mean? What are you talking about? Right, okay, so that's the one here. And then this is also a very typical question in the exam. If an integer in binary form is this 10010011, what is the next integer in binary form? And also in base 10. So binary form means in base 2. So this number is actually base 2 here. What is the next number in base 2? Well, actually, we're going to do plus 1 here. So this number plus this one here. So you need to know how to do addition in base 2. So in base 10, every time you see 10, you're going to do carry over. In base 2, you're going to do carry over whenever you see 2. So 1 plus 1, that's 2. We're going to do carry over. 1 plus 1, that's 2, carry over. This is 1, bring down here. There's nothing here, right? If you have, okay, only 1 here. And we're going to have all the leading zeros in front of it. And then for others, right, we're going to just copy them down. So that'll be the last 4 digits, and we're going to just copy the first 4 digits. So this will be the next integer in base 2. We're going to write 2 here as a subscript, indicating that's base 2. And we're going to convert this number in base 10. So this is also a typical problem. How to convert a number in base 2 to base 10 and vice versa. So base 10, if you have a number base 10, that means this 1 means 100. This 2 means 20. 3 means 3. So each digit, right, should be multiplied by the weight. The same thing here, you're going to multiply each digit by the weight, but then the base is not 10, base is 2. So here the base is 1, here the base is 2 to the power of 1, 2 squared, 2 cubed, 2 fourth, 5th, 6th, and 7th. So you're going to multiply 1 by 2 sevenths, that's 128. 1 multiplied by 2 fourths, that's 16. 1 multiplied by 4 here, that's it. And you can add them together. So that'll be 20 and 128, that'll be 148 in base 10. So if you know it right, it will be easy. If you don't know it, well, you just need maybe 10 minutes explanation to understand it. So do you think this is hard? Actually, it's not. So back to what we talked about earlier, right? The APCSP exam actually is not hard. You just need to know what it is being tested and what the concept is. If you know the concept, if you know the idea, right, then it's actually easier than other AP exams. Okay, here is another one, maybe a little bit interesting. So for example, I have a diagram like this one here. So start from, say, the lower left corner to reach the upper right corner. Describe the movements that follow the arrows. So we're going to go like this one here, and here, and here, 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 and here. So how do you describe it? Of course, again, right, you're going to be provided the 4 choices. But if you want to describe it yourself, right, how do you do it? So I'm going to say, move forward 1 step, turn left, move forward 1 step, turn right, and then move forward 2 steps, turn left, move forward 2 steps, turn right, move forward 3 steps, turn left, move 3 steps forward, turn right. So basically, you see here, right, we're going to do the, it's not going to be like this one. It will be, the options provided will be, say, repeat or doing the loops. Repeat how many times? It will say repeat 4 times. So this part will be 1 time to do the repetition, right? This will be another one. This will be another one. So it will repeat 3 times. Every time you're going to go this one here, forward, left, right. So moving forward, and then turn left, and then moving forward. No, I'm sorry. Going forward, turn left, and forward, and then turn right. So forward, turn left, moving forward, and turn right. Next time, again, moving forward, turn left, moving forward, turn right. So there'll be the 4 steps for each part of the repetition, each iteration of the repetition. So you're going to do this one here. And then for each time, you're going to see, right, here, first time, the number of steps would be 1. Here would be 2. Here would be 3. So you're going to change the steps and then repeat this. So you're going to see the code, the options given to us, right, would be, say, how do you change the steps and how do you do the forward, left, forward, right? Maybe the order will be a little bit different. So notice here, right, I can maybe change. I would say, okay, move. If you are not so sure, right, I'm going to say, this one actually is not so confusing. I mean, there's no ambiguity, right? You have to go forward here because the arrow is pointing to east. If you're not so sure, I'm going to start from here, going up, turn right, going up, turn right, going up, turn right. But then this one is a little bit different, right? You say going up 3 times, but you don't turn right and it goes 3 steps forward. So be careful for the order of the components. One of them must be the the right answer. So if you're not so sure, then just run it. Assume you are the computer, or you are like, this is a turtle graphics, right? Assume you're the turtle. Follow the instructions and see whether you can reach the final destination and with the right orientation. but this actually would be the foundation of later what we do the actual computer programming. So you have some idea and you want to convert or translate the idea from, say, an English description to actual computer power code. So this actually is very important. As we said earlier, right? This class actually will prepare you so that later, right, you're going to be very fluent, very efficient to develop programs to solve a problem. Okay, so since most of you guys, right, are not actually taking the AP-CSP class, and also will take the AP-CSP exam, so you're going to have more chance. So not going to take maybe this May, but maybe you're going to take next May or even later, right? Anyway, so this will get you prepared. Okay, if I have any question, you can ask me. And we have a very friendly front desk. Any question there, right, will be answered. But since we're here, right, any question that you have for me? All right, okay. So I understand this one here. We're going to offer, this class as a very small group. Last May, we had a group, I think, with only 6 students. So we should have enough, practice. And if you have any question, right, we pretty much all the time, right, we're going to figure out all the mistakes and answer all the confusion, clarification problems in class. So that'd be convenient. And since this class will only offer for 6 weeks, all other classes we're going to offer 12 weeks long, because we understand it is actually short. And with the AI coming, many students will find out, yeah, okay, I think I can get the help. But be careful, AI can help, but sometimes the solutions from AI may not be accurate, so you need to double check. Okay, luckily we do have the resources right from College Board, so check all the available resources, then you should have the confidence to get a 5 if you do take the AP exam. All right, okay, that's all for this open class, and I'll stop here and looking forward to seeing you guys in the future.